This is episode 1 of a brand new series on a commercial electrical design starting from scratch. We're going to use the 5-story Snowden Towers example architectural project from Autodesk, and we're going to create an electrical design from the ground up using many custom symbols, custom families, custom panels, and I'll show you links to videos on how to create all of that custom content so that you can have a professional looking and professionally connected project, including all of the equipment like elevators and getting solar ready to the roof and EV charging points and all the lighting, all the power, and getting service equipment and panel boards and meter centers, most everything you can think of for a multifamily and mixed use kind of project. So stay tuned for this episode and all of the rest. It's going to be a bumpy ride. Let's get right into it. So the first thing we're going to do is get an architectural Revit model that we can use as a background for our electrical design. So what we're going to use is an out-of-the-box Autodesk sample project. And if you just go up and search engine your Autodesk sample 2024 Revit sample projects down here, try that. And in this, you will see this one project under 2024 called Snowden Towers. And this has all of the trades in it, even has an electrical. Now, because we're going to start electrical from scratch, we don't need it. You could download it and take a look at it and see how that consultant designed it. We're going to design it a little bit differently because each area of the country, of course, each country, and then even different firms have different ways of presenting their plans. So we'll do it with our methods. And so let's just bring in the architectural itself. So if you click on architectural, it will download up here, and then you can open that up. So let's go into Revit and get this opened up. And if we go into Revit 24, we can open that up. In my ER folder, I have it under an XREF. That's our old CAD naming, but we also use it for linking in architectural files. So here's the Snowden Towers sample architectural right here. Let's open that up. Now this is a more advanced project. It has 5 levels and a parking level. So it's a good sized project, but it will show a lot of techniques that you can use to design and document your own project. So here it is. And they've given a rendering of the front of it, and it includes these 3 tower areas, modern, and then they also have an old-fashioned facade in front of that. So what I like to do first is to examine the architectural model to learn some things about this project and some specific Revit things like levels and how they've divided up views and what scale are they doing things in, even how do they name their sheets. So you can start here by going through the sheets. I also create a PDF set. I export PDF or print to PDF a set of these for reference during my electrical design. Because when we link in this model, the link isn't always enough to show you what you need. You won't see notes, things like that. So let's take a look at this. They have the G drawings, which is the cover. And then they have, of course, some learning aspects because this is a sample project. They have parking deck, and then they have life safety plans. And if you're familiar with commercial design, you'll notice that architects have these life safety plans to show exiting from the various rooms and buildings and how far that exiting path is. Green line it's almost 50 feet. It takes 11 seconds to get out. And this will give you an idea if you're doing lighting design at all, where exit signs may need to be placed, what is a path of egress, things like that. Maybe somebody else is doing lighting design and you don't need to worry about that aspect of it, but that's what these life safety plans are for. So let's get into the actual floor plans. A100 is the parking deck. And this is the architectural floor plan for the parking deck floor plan. And they have a graphical scale. They're laying theirs out an 1/8 inch, which is very common scale. Shows the north arrow. So true north is a little bit off to the right. This would be set up as project north so that the plan is horizontal vertical. We've got grids 1 through 9. It has a diagonal on this side. We have a number of parking spaces. Here's the drives in and out. We have an elevator E1 with its machine room, some stairways, 3 stair towers. We have another elevator, E2, elevator 2, and its machine room, and then some storage behind that. And then down here, this is probably some storage, and we have this utility space, which will become our electrical room. Main electrical room will be down here in the basement or parking level 1. And this brings up a good point where let's take a look at what levels do we have in this building. So we're still here in sheets, but we can look at building elevations to get a good idea of the actual levels and furthermore floors in this building. So for example, if we look at this, our building starts here and goes to the left, clear down to here. Now they don't have grid lines on this view, but what we can see is that it looks like a sloped floor. The street or grade slopes up. So these doors are a little lower than those doors, which are a little lower than those doors. So we have a stair-stepped floor. And then these are even lower. So we'll have to deal with that. And what you can see over here is we have the parking level, and then we have level 1, block 35, another level 1 at block 43, which is their 00. And there's an interstitial level in here too, which they don't show on this view. We have an M1, which ends up being a mezzanine. So there's some things on a mezzanine level. And then we get to level 2, which would be floor 2, second floor. L3 will be third floor. L4, and then 5 are the fifth floor. And then we get to what they're calling a roof 1. So part of the building is on roof 1. And there's another roof 2, parapet, and roof 3, and another parapet. So you can see that this is a complex building with multiple levels, stair-stepped floors, stair-stepped roofs. So everything you can run into on a project, which is a good complex project to learn some techniques. And, real life projects sometimes end up being like this. So it's good to have these tools in your belt. And this is just the north view, not the front view, the back view, which ends up being the north elevation. And it's just windows and balconies. Some of the other elevations will probably be east and west. And this is an elevation of just the isolated front with this very decorative old look. And up top, you can see there's some kind of a trellis thing up here. But again, all of these different levels that we will have to take a look at. And then they do building sections as well. So we can see how things look if you cut the building in half longitudinally. And we can see we have a cafe down here. But let's keep looking at these floor plans. Now that we know the levels, we already saw the parking level. Let's look at the first floor plan, which had, 2 or 3 different levels itself. Now they have it all on one sheet, one plan. We have here from left to right, our elevator. It's a cafe kitchen. So a small kitchen in here and a small cafe with its restrooms. The stairs. And then we have a commercial/retail, most likely a tenant space. And it's not fully fitted out. So this is probably just a empty shell for a future tenant, for a future TI, tenant improvement. And then we have the residential lobby with a revolving door and regular man doors. And it goes upstairs here. And this goes up a couple steps to another level to the elevator. And then in the back, we have some utility space with a trash chute. So that's what's going on there. And then here we have another storefront with a commercial retail space with a couple steps. That's a large tenant space with its own restrooms. And then we have another commercial retail tenant space with this entrance and restrooms and some utility areas. So we've got like 3 retail tenants. We've got residential in the middle. We've got the cafe on the left. That's level 1. Second floor, we have this mezzanine dining area, and this is open to below. Go up the stairs to the mezzanine for the cafe and the dining. And then over here, we have a live-work unit, so a residential/commercial unit, a studio, a 2-story studio, another live-work unit, This is open to below. That's the residential entrance. And then this must be open to below as well with the X. And this is also open to below. So these commercial spaces are rather high. They go up past the second floor. Now, third floor plan. Again, we're just getting our bearings so we know what we're working with here. On the left, we get the office unit. So maybe an office tenant, another TI. And it has the unique slanted modernized front. There's an elevator serving that portion. And then we have more studios. Here's the top of this two-story studio that had a spiral staircase up to it. Another live work unit. This is open to below. A live work, live work, live work, and live work. So a number of live work units that all have, looks like little kitchens or kitchenettes in them and their own restrooms. So we have a lot of equipment there. Fourth floor. We have another floor of office tenant studios and this more 2 stories and live works. So a lot of residential up here above those retail tenants. Another office unit, studios, so very similar. Now we're up here, we have a green roof to deal with on level 5. A private patio out here for this live work unit. And then we have a green roof level, and it actually has some color on here. So this is showing what it's made out of. We've got decking and tiles and turf, but this is one of the roofs. And this looks to be seating area with stairs. So maybe some kind of a viewing outdoor area with that trellis thing here. And then another roof plan. And that may include the roofs of some of these taller little buildings above the stairs, stair tower, and elevator overruns. And then we get our ceiling plans. Now I notice we don't have a parking deck ceiling plan. They jump right into the first floor. So that's an issue. I should say that they're stating that this project is partway through design. So it's not 100% done, ready for construction. And you can tell because the architect hasn't said anything about these lights. Now, these are symbols for lights, but they haven't called out what they are. And maybe this job has an interior designer that's doing the lighting, and it would be on their plans. We don't have access to those, so we will have to investigate the model and figure out what's going on with those lights. But they show the lighting, they show the ceiling types on here, and second floor ceiling. So we can go up and take a look at all these ceilings. And we're going to be bringing this into our electrical model, so we'll have access to all these locations. Take a look in 3D to see what this building looks like. It'll give us a good lay of the land. Now, 3D views can take a while to generate. So that took a couple minutes to generate, actually. But this gives us an idea. Here again is some pictures, some 3D renderings of the building itself. There's the back of it. Interior renderings, so you can see some of the staircases. So this is like a 3-story entrance. Nice big area. Here's some of the other areas. You can see they're open for future tenants. They even have some of the structure in here. We do have a structural model that we can bring into this. And another thing I'll bring up is we have the mechanical, HVAC, and plumbing models to bring in as well. So we will bring those in eventually for coordination purposes, so we can show how we can coordinate with those other trades with our electrical system. And some of the cafe areas. So this kind of gives an idea of what it looks like. We have a good idea what this is, but I want to show you some now the Revit details of this. We need to get into the nitty-gritty of how this is put together by the architect to help us decide how we will put it together and deal with it in our model. So if we go down to the actual floor plans themselves, the floor plan views, not the sheets. So we go to parking, and this is where we can actually get to all the pieces. You click on things and you'll see that it's a parking space, and these are just some lines and some annotations. But we can see that this parking level is created on associated level is parking. And then if we go to level 1, we know we have 3 level 1s. So this is going to be the tricky one. What level is this view created on? It's created on level 1, block 35. Now back when we looked at the section, 35 was the lowest level down here. And you can kind of just click somewhere, and what I'm done is I've clicked on a floor. And if I click on a floor over here, do it again, click on the floor, there we highlighted it, we're on the floor. It is on level 1, block 35. The cafe floor is also level 1, block 35. Now let's keep going to the east here. This floor is on level 1, block 37. So it's at a different level. It is actually hosted to block 37. Keep going to the right. We have block 37, 0. And then we have this, which is block 37, but it's 1 foot offset from block 37. So it's 1 foot higher, and that's why we have the couple down steps to get to actual block 37. So we have a number of different levels to deal with. Even just within that one level, block 37, we have multiple levels in here. And in the back, block 37 at 0. What is this one? Block 37 at 0 and block 37 at 2 feet. So this level is 2 feet higher. And the reason I bring this up is if you want your receptacles, for example, in this space to actually be at the proper level in 3D, we will have to make those adjustments. And also it will matter how we assemble, how we create our views and working views, coordination views, to make it easier to install receptacles and other devices, light switches and such in here relative to these different levels. And then finally, this guy is at level 1, block 43. So we have block 35, block 35, block 37, and block 43. Like I say, when they put these things in, because of these different levels, if you set this whole plan up to block 35, the architect wanted to install a wall. They want the wall to go to block 37. Well, you would have to manually go in and say, extend it to block 37. Well, what they've done is if we go down and look at what they're calling their floor plan working views, this is a good example of you have production views, sheet views that get dragged onto a sheet for like a finished product. But then you also have other views which are just used to assemble this model, to create this model. And they won't get dragged onto a sheet. They're just for working in a more convenient layout. So for example, we have rooms for L1 block 35. They've got one for L1 block 37 and for L1 block 43 for the 3 different levels. This one happens to be rooms. So for example here, this area here is set up to block 37 is the associated level. And they've narrowed in the crop, so it's only dealing with certain areas. So we can take a hint from this. When we're creating our model, we may want to have some areas that are set up to the different levels. However, we may want to present them all on one floor. So you can see that they've split things up so that this can be on block 43. So that's one thing you can do, is have different views. But in the final view, to make things look properly, you may need to do plan regions in some areas. I have a video that explains view range and the plan regions, which are areas that can have a different view range than the default view range. So the view range, which deals with the vertical aspect of this, the bottom level is this associated level, which is the lowest, level 35, block 35. The cut plane, and I cover that in that video, but in short, the bottom of it, the cut plane is where it's cutting the walls so we can see furniture, walls, stairs at a certain level. And then we have the top up here, which is the top boundary, is at 7.6. So that's the standard view range. However, to see what's going on in these other areas that have different floor levels, they've had to create a plan region. So let's see if we can find a plan region in here. They are hard to find because they're a tiny little dashed line. One trick I use is I can go over here to this view template and bump up the size of the plan region line work so that it pops out. It's an annotative element. But if I go down to plan region, they are turned off. So let's get those turned on. And I'm also going to make the line weight something like 10 so we can really see them. There they are. See these green lines? That one there is a plan region. And its information, let's click on it again. There. It has a separate view range. Now its view range is based on block 43, which is this high level. So this separate area is set up with block 43 in mind, bottom, and then the middle is 4 feet above that, and the top 7.6 of block 43. So that block 43 looks proper. Now this center portion, this one, and they overlap. So there we go. This one is set up for block 37, the middle block, 0, 4, and 7.6 for its dimensions. Now, one thing you may notice is there's a little bit of a odd pattern down here, and we'll get to that in a minute. But the furthermost left one doesn't have a plan region around it because it by default is the level 35. So this is the default level. The other two have their own plan regions because they're set up as different levels. Now this center portion here, in here we have another little plan region. And what's that? That is set up with block 37, the middle region. However, the cut plane's high at 9 and the top goes clear up to 25 feet. Now, my hunch is they've done that so that they can see most of this stairway. Because if we don't have the plan region, let me move this plan region. Let me change it so that we can't see the plan region, just to see what happens. Move the boundaries. If we don't have this separate plan region with a higher cut line, and it takes a minute, see what happens. The slash for the stairs is way down low. And so we wouldn't see the stairway. So what they've done, let me undo this. What they've done is created a plan region so they can see the stairway better. So they've created a different plan region. But that's how you can control the view range of different areas of your plan, because it's based on a default level that you have to set the plan up to as level, and then you can adjust it. So we can use these same techniques on our plan to make things show up properly. And again, if they hadn't used this plan region, let me get rid of this plan region as a sample. What happens to this last block? You can see, because it's set up for the lower floor plan, our cut line does not cut through the stuff that's on this floor. So undo it. Now we've created a plan region so we can see the walls of the restroom and all that. So again, that's what plan region's for. And if you're getting anything out of this video, I'd sure appreciate you hit that thumbs up like button. And also, if you want to see more of this and see the rest of this series, hit that subscribe button. I really appreciate it. Drop me a comment. Let me know what your experience has been in your Revit electrical journey. And let me know if you have any questions or concerns, and I'd be glad to help. And then level 2 and on up are very straightforward because they follow a full level, except for this mezzanine. So we have that M level. This mezzanine floor is set up for the M1 level. However, this whole sheet, this whole view is set up with level 2. So again, we have one little area, and here it is. Here's the plan region just for this area, and it is set up for level 2 with an offset. They also could have set this up for the M1 level, but either case, they've set up a different view range for this mezzanine area. And then we also see some more plan regions right here. There's a little one here that was set up. They've decided to set this up differently, referencing different levels. Maybe they wanted to show this window detail that's up high that you wouldn't normally see on a normal cut. Same thing here at this residential area. They wanted to see this staircase differently with a different range, and this facade they wanted to have a different range. So you can have different plan regions to show different cut planes, different heights, and things like that to show it the way you want. And we may not need to do this for our purposes if we don't have any electrical But if we want the architectural to look right, we may have to come back and do what they've done. So you can see, analyzing the architectural model gives you some of the Revit clues that you wouldn't normally see when you bring this in as a link to your electrical model. And we'll do a quick finish review of this, and then we can get into our electricals. This one has no plan regions, so we're getting simpler now. What happens when we get to level 5? Same thing, that all works. Even the roof works with level 5. It happens to be the roof of the level 4 there. Now we have roof 2. We never did use roof 1. So roof 2 is a good level to use. And then roof 3, and I don't see any plan regions here. And then roof 3 is a good level to use as well. So that gives us good clues as to what levels we want to use. And you may want to take a note of this or just memorize it, that we're using roof 2 and 3. And the last thing I like to do is look at their title block. So go back to our first floor plan. We want to make sure that we have this title block available for our project. So what I will do is I can edit the family and save it, or I can click on this and I see it's E1 3042 horizontal Snowden. I can go down and find their title block under families, annotation symbols. And again, this was called, in this version of Revit, we can actually right click it and say, find in project browser. That's a handy button. So there, it opened it up for us over on the left. That's helpful. And what we can do is right click and just save it from here. And then we will save it into most likely our reference folder. And I just save it with one backup, save it. Now we have it available to bring into our electrical model that we are going to create. So we can close out of this model. We don't need to save it. And we're going to start a new electrical project. So new, depending on which Revit version you're in, you'll find different templates. Some will have an electrical only template, some will have an MEP, systems, and so you'll have different ones. So what we can do is browse their folder, and in this version, we do have an electrical default template we can use. Now I'm going to use the electrical template that I customized in that video. So I'm going to go find that. That's here in my ER folder, ER electrical template. And it's based on Revit 2022, but I can use it for anything 22 and above. I'm in 24, so that works. And let's open that. And say, yes, okay, we're creating a new project, not a template. And it will convert it. Just a quick review. Templates are typically created for the oldest version of Revit that you anticipate using for projects. Now, as a consultant working for others, we work for architects typically. We have to follow suit with whatever version of Revit they are using. So if they're still in Revit 2022, we have to be prepared to set up our model that way. So that's why 22 through 25, right now we're using our 2022 version. Our office standard is to have a template for every other year, the even years. So we will be creating a 2024 as well. But frankly, right now we haven't done many projects in 2024. So here we go. This is our starting view we had. And it was just a simple text starting view. The first thing we do is go into a floor plan so that we can bring in the architectural model as a link. So we'll go into first floor power plan. And there we are. And it is cropped. So right now we can uncrop it. And let's go ahead and bring in that architectural model. So we want to insert, link a Revit, and let's find that Snowden Tower sample architectural right there. Now, take a look before you hit OK. Don't just say open. We want to go down. We want to make sure we bring it in properly. Now, there's a number of positionings you can have: internal origin to origin, center to center, shared coordinates, project base points, manual. What I would recommend is try to go project base point to project base point. That will get you at least lined up horizontally and vertically. The architectural will come in matching your project base point. And then we're going to acquire some coordinates from that architectural model to further refine, but we want to be the same project base point. And that may take a second to load in. It's a good size model. That architectural file has a number of links in it. It has all of the other trades linked in, and we're not going to see those because they are linked in as overlay, which is okay. We just need the architectural. So here is our architectural model. It comes in. Now what I would like to do when this comes in is lock it in place so I can't move it around. So I'm going to pin it. The next thing I like to do is to bring in its project information, which may have further information on its coordinate system. It'll have the project title, things like that we need for our title block. So let's go up to Manage, Transfer Project Standards. And this is where we're going to find a number of standards we can bring in from that project, but all we need is one. So let's check none. All we need is the project info. So down here under project info, check that, say okay. And it's going to bring in energy settings, location data, which is important. We want to match their location data, the project information, like the name of the project, and then some site information. And we want to overwrite ours. So there, we've done that. And the other thing we want to do is under coordinates, we want to acquire coordinates from our linked model. So we want the architectural model to have the master coordinates that we want. So acquire coordinates and click on the model. Coordinates are not acquired because the selected link has the same coordinates as us. So we're already good. We already match. We just want to make sure. So now we're all matched with location. And then the next step that I like to do is get this saved right away and get it named the way we want to. So file, we will save it as, it's a project, and get it saved as, I'm putting it in my ER directory, and I'm going to call this ER Snowden Towers. And I want to get electrical in here, and I want to know what version this is, R24. Now we have that saved. We're good to go. Now, if you're in a multi-person firm or department that you will have multiple people working on this project, you may want to now set it up for work sharing so that multiple people can be in this model at once. And you would do that in the Collaborate tab, and you would go to Collaborate and do all of that. I show that in some of my other videos, how to set up work sharing. That also allows you to use work sets. In this project, I'm going to go without work sharing to show you that you don't need work sets to control visibility. In fact, I recommend that you don't use work sets for visibility. We're going to use filters instead, so we'll get into that later. But for now, we're not going to work share this. We're going to treat this like you're a one-person shop. It's just you working on this alone. The next step I like to do is to get my levels that I need brought in or adjusted for this project. Now, what you can see in my template, again, you can refer back to that video, is I have set up 5 floors, which means I have 5 levels in my project already set up. So I don't have to add those and create views. I've already got views created in my template, which saves me a lot of time. But I need to adjust the levels to match the architectural levels. We saw there was a number of different levels. So what you can do is go to an elevation or a section. I don't have a section created yet, so we'll go to a south elevation and look at the south elevation of this project. Now what we see is these guys in blue are my levels in my project, and then these other ones in black are the architect's project. And we can see some of the levels in here, and they're kind of scattered around, hard to find. So that is always a trick, is just trying to find where these levels are so that we can match them. And depending on how these have been dragged left and right can determine what you see in different views. Let's go back to our floor plan view, first floor power. And we're going to create our own section in hopes that we can see all of these levels. So up here, the section tool, I'm going to drag left to right and just create my own section. And if I double click on the head of the section up here, this arrow, now I see a section and escape out of that. Now I can see all my levels. My parking level, 35, 43, 37's in there. Now I can move these levels to match theirs. I need to find my levels. There they are. And I like to separate them so I can tell mine from theirs. So what I'm going to do is I'm going to make level 1 match this lowest block 35. I'm going to need to add a level for parking. And I'm going to need to add some other levels for these others. So let's move this guy, and I'm just going to align it to this level. So I go to there, and then from here, and it aligns it. And so that's level 1, and I'm going to do what they did and call it L1 block 35. Just stay consistent with their naming so I don't get confused. And you can see that our negative 5 feet 11 inches matches their negative 5 feet 11 inches. Some projects, if you didn't do all of that acquiring project info or acquiring coordinates and all that, you may find that your levels are different. And so that's why we do that. It really comes down to where that project base point is, or even where the survey point is. There's a number of different coordinate systems in these projects. Now I want to create another level 1. So let's just copy it. We're going to copy here, from here, up to here. And I want to go straight up. And then I want to align this level. Align to 37 from there. And I'm going to call this. Now I may want to change the scale of this so my letters are smaller. So if I go from 1/8 inch to 1/4 inch, it means my annotations in effect shrink. So I'm going to call this on block 37. It just added 36 on its own. And then I also want a block 43. So there, I'm going to copy this from here up close, keep it perpendicular. And then I will do my align tool to make it exactly match block 43. I need a mezzanine. Let's copy this for a mezzanine and then align it. I'll just call this M1. And then level 2 I already have, so I can just align it and change its name to match. And I just did a break there. I didn't mean to do that. L2 and then L3 were actually, interestingly, they were close. Get that changed to L3. L4 aligns there. Another way to do this is to only have 1 or 2 levels in your template, and then you can just copy and monitor the architectural levels. And that's another technique that we've used. But then you have to create all of those floor plan views each time. And we've decided that I'd rather have 5 views made. It saves some time. And if I only have 3 floors, I can just easily delete the extra views. It's easier to delete than it is to add. And then we decided we don't need all these parapets. And I think we decided too, we didn't even need roof 1. We needed roof 2, which I can't see here. Let me change the scale yet again. 1/2 inch. There we go. We can see roof 2. So I'm going to copy this up to roof 2. That's why we looked at the architectural model, is to determine which levels we need. So roof 2, R2, and I think we even had R3 in there. Now, I don't know if we need R3 because I think it's just the roof of these stair towers, which we have nothing on. So we'll leave it off for now. We can always add it later. But there we have our levels, and we need to add our parking level, I just realized. Let's go ahead and copy this down to the parking level and get it aligned. parking. Okay, so now we have all the levels we need. And then the next thing I want to do is I want the grids from the architectural model into my plan so that I have control over them. I don't want to rely on where the architect puts them. In some of my views, I may want to move them around. So let's go back to our first floor power plan. And here's our grids. We have 1 through 9, and then we have A, B, and even a B1 through E. So we want to get those in. Now, a couple different ways you can do this. You can go up to the architecture tab and start bringing in grids and things like that. However, in this case, I like to copy monitor these grids, and it copies them exactly where they are here. What I do is go up to Collaborate, Copy Monitor, and monitor just means it's going to monitor if it changes. So if you open up your project sometime later and you get this notice that, hey, you need a coordination review, that means something changed that you were monitoring, or some walls moved or something. So this will kind of give you a little warning if things move. But we mainly want to use the copy. So we want to select our link to make sure, in this case, we only have one link, but we want to make sure we're using our architectural link. So you kind of hover over it and you'll see it light up. Click on there. And then we go to actually copy. And it does a copy and monitor, even though it just says copy. Now we want to copy, monitor multiple grids. So click the multiple button. And then when we're done picking our grids, we can say we're finished. Now I can try to go through and pick individual grids with control, or I can simply surround the entire project. I have everything highlighted and use the filter. This little filter here is very powerful because I say check none, check grids. Voila, I just picked 28 grids with like 3 clicks. Okay, now I need to finish this selection. I'm not finishing the copy yet. I'm just finishing the selection. I'm finished selecting. And then I need to go back up and hit copy monitor again, and now say finish the copy monitor. Now if I highlight over these, you can see that they are in my project. I have control over them. I can move them around. Now, when I move these around, now this guy didn't stick because he is not exactly parallel. But you can see I still have the architect's grids in here. Now this is where I need to go in and change and turn off the architectural grids. So what I'll do is I'll go into my Power Plan 1/8 inch view template, which is part of my project template. Now I can go in here to the actual Revit link. I want to turn it off in the architectural link model. Right now it's set up to be controlled by the host view. Well, my project is the host. So my project is saying keep grids on, so they're on in the architectural. I want to change this display setting of the linked model to be a custom view. And I want to go to the annotations and make those custom. And this is where I want to go down to the grids. They're an annotative element, annotation. So I'm in my Revit link. This reminds you that you're in the Revit link because these menus all look the same. I'm in my link, go down to my grids and just uncheck that to turn it off. Okay again. And then there, the architectural grids turned off, and all I have left are my grids. And I can move those around at will. And this 43 has to be moved because it's diagonal. So there, we have our grids copied, and we can move them around as we like. So now that we have levels and grids, we can proceed to make the rest of our floor plans that we need. We've got 1st through 5th already, because that was in our project template. But now we need to make a parking level, and then we have a mezzanine level, and we need to set things up for those. And we'll need to set up some of these raised areas as well. So let's go ahead and do the parking level, and that is simply go up to View and Plan Views, and we want a floor plan. We're going to do the floor plan first for power. This shows you the floor plans that have not yet been created. So we have the other 2 levels that we can make. We have the mezzanine, we have the parking, and we have the second roof that we can do. So let's go ahead and just kind of an orderly fashion, let's do the parking level. And there is the parking level. And we know it's at the right level because we set up the levels earlier. And then we need to give it a name. Now I want these to be in order. What's between 0, and 0, 1? Well, I can use something like a 0.1, any system you want. This is purely for organization. And we'll go parking, level, power. I don't want to rename the level for that. Now we can just pick them all, but I don't actually need these two other L1s to be production or sheet views that I drag onto a sheet. I'm going to do it all in one. Now I may want to make some coordination views for these. So let's do it that way. Let's make these coordination views. So this one we're going to make a 101.1. I do these in lowercase. First floor, we'll call this block, I think it was 37, plan, and we can just call it whatever we want. And then the next one, and I do these one at a time just to keep them straight, block 43. So 101.2, first floor, block 43, plan, coordination. And then we can do the rest. M1 and R2, let's select both of these. We can select more than one at a time. And we will call this, it's between 1 and 2, 101.3. And this is actually going to be a production view. So we'll call this 01.1, mezzanine, floor plan, power. And another, the second roof will be a production or sheet view. Plan, power. So now we have the rest of our power plans set up. We'll need to set up lighting plans. We can wait to do those until we actually get into our lighting plans. I'm going to start off with power. So let's go down to the parking level and see what we have down here. One of the first things I like to do on a plan is to get the room names in there. Now, some people use spaces, and so they will create, it's an analyze issue, and they'll create spaces. You can do rudimentary lighting calcs with these if you want, just a kind of an average lighting calc. We do our lighting calcs outside of Revit, so we don't do that. And then for the HVAC folks, they like spaces so they can do some volume calculations, things like that. But for our purposes, we found that we're fine with room names. So that's how we're going to proceed. So we're going to go with annotate and do room tag. And the areas in blue have an actual room entity assigned to them. So we can place a room tag directly on these areas that have the blue. So that's the stair, and this is the machine room for the elevator. This is the main parking garage, so we'll get this out here in the middle. And these can all be moved later, which is very handy. That's stair 2. And we have the elevator E2, and this is another machine room and a storage. It's so nice having our own room tags on our own plan. This is the utility or electric room. See, this does not have, it just says utility because that's what it was last. Or if I go from parking, that's what I had last. This space here does not have a room assigned to it. So we don't really know what it is. And then I want to get this guy. He doesn't follow very well the rules. We'll get him in there. So we have our rooms tagged. Now some of these rooms, especially at 1/8 inch, the tag becomes quite large. So one thing you can do, I can do it when I tag it, or I can do it now. Once you're in here, go over here to leader line, and then grab the little arrow and move this out of the space, and it leaves a leader. And you can pull this down here and do that how you like. You can also change these to have a ball or an arrow or whatever you want at the end. So if you go to edit type for your room tag, the leader arrowhead says none right now. We can put that into a dot filled. I like using a dot so that it's different than an arrow, something like that. And same with machine room. Go over here to leader line and Now, if you grab the wrong thing, I got lucky there, but if you end up grabbing the circle and pulling it outside, you'll get the question mark. So that circle has to be in the room. Pull that out and get that lined up. So we can do that for these small rooms. And that looks good to me. So now we have to make the determination for our workflow. Now, you may have a certain workflow you follow when designing a building. A lot of times we like to get the loads in first. So I mean the receptacles, the motors for HVAC and plumbing, and the lights, and all the loads in first before we start circuiting anything. And we may send a whole set of drawings out with just the loads shown as a schematic design, or even a design development level. And then when we get into CDs or construction documents, the next phase, then we will start fine tuning. And a lot of that phase is rearranging some of these loads to keep up with the rearranging walls, which always happens, but also refining that and adding some electrical distribution and starting to circuit things and add up loads, things like that. So there's kind of an order to this progression that we follow. So in this example, I'm going to break it up a little bit. I normally, again, just do a full project, and that's how I did my previous project. I did a full project with laying out all the receptacles and motor loads, and I didn't circuit till I was done. This time, I'm going to break it up because of the video format. I will lay out the loads in this parking level, and then I will also start with some distribution so that I can at least get level by level circuited, and then we will tie it all in together with a full distribution system, get some feeders modeled, and we'll go like that. So what are we going to have down here in the parking garage? We've got elevators, so we can start there. To find out what you have for these various pieces of equipment, you can look at shop drawings or even catalog information from the vendors about what they need. You know, over the years, we've learned what elevators typically need, and it changes constantly. But the latest is when you have a separate machine room like this, they're going to have a 3-phase feed to the elevator motor, whether it's a hydraulic pump for a hydraulic elevator or whether it's a traction elevator and it's a 3-phase motor. But there's one big disconnect, usually fuse disconnect feed to this elevator. So I'm going to show that with a motor connection. Now, the other thing I need to mention in this tutorial is I'm going to be using the custom content that I use on our commercial work. My previous project series, I tried to use as much out of the box as I could, just so people can work through that and learn it without needing a bunch of custom content. But in this one, we're going to go ahead and use the custom content, and I have videos to show you how to create that custom content, or you can create something similar for your needs. I'm going to do it that way this time. So let's go down to my electrical fixtures. So these loads or endpoints are actually fixtures, whereas the panels and switchboards are electrical equipment. So what I have in here is a receptacle, equipment connection, and a motor connection. So I want this ER motor connection, drag it in, and you can see the symbol I have is a little motor symbol with a fuse disconnect. So we're going to say that's in here somewhere, and we can coordinate that eventually with the shop drawings. So what I do here is this is an equipment connection. It's just a symbol, but it has a power connector. So there's no 3D associated with this. This is just a symbol. I like to assign some voltage and load to this when I enter it, even if I have to change it later. I at least want to get it close. So I'm going to create a separate type for each motor connection because the type contains this information. It contains what classification it is, how many phases it is, its voltage, its load. So that has to be separate for each kind of piece of equipment. So load classification, I'm going to further classify this motor as an elevator. If you didn't have elevator in here, you can always add it. These are easily added. So elevator, and it's going to use the elevator demand factor. It's 3-phase, and it is 208. Let's say that I found out from the manufacturer that this is a 55 amp, accelerating load, because elevators have not just a horsepower rating, but they typically have running load amps and then an accelerating amps and things like that. So I'm going to base this off the accelerating worst case amps of 55 amps. Again, you get that from the elevator manufacturer. So if I don't know how many VA that is, I can insert a formula in here. So I can just type equals like a spreadsheet, equals 55 amps times, well, 208 three-phase is 208 times square root of 3, which ends up being 120 volts times 3, or 360. So 360 is the magic number for 208 three-phase. So 55 times 360 will give me the VA. It's almost 20,000 VA, 20 kilowatts. And then the way we use our mechanical equipment schedule is we use this little guy here called type comments to flag whether I want this in the equipment schedule or not. Well, I don't want the elevator in the equipment schedule. I only want HVAC and plumbing in the schedule, so I will not flag it. And I have other videos that show how I use that flag to filter my schedule. And then down here, the type mark came in from before as an EF1, but I'm going to call this ELEV-1 for elevator 1. And I can put a description for myself and call it the elevator. And then also I want to make sure my type is renamed properly. I'll rename this first one, and from the future I need to duplicate it first and then rename it. So let's rename this one as elevator 1 also. That is just how it's going to show up in my list over here on the left. And then this is how it's going to show up when I tag it. So, okay. And then I can actually tag this. Go up here to tag by category. It has a leader, which I like. So then I can just hit that and then come out here. I'll hit that and it tags it there. And then I can take this and move it around to where I want. Kind of like a room name, elevator 1. And that has my special symbol that I've created, a custom symbol called ER electrical fixture type tag. So it's tagging the type mark. And then also in the machine room is a convenience receptacle. So over here to duplex. Now I need to bring in my custom duplex. This is just out of the box because it doesn't have the ER in front of it. I have a whole folder of my custom content and I can bring it in from there. Normally I would have that in my template, but as I'm still working on my template, it's not there. So load family, and it puts you into their default folder for family. And I have ER duplex receptacle right there. And I'm going to be having a EV charge station in here as well. So let's get, that's a bollard, which will be fine for this situation. Okay. And it up converts them from 2020 or 2022, whatever you made those in. So here we go. So now I can just get rid of this duplex receptacle and use my own. The only thing different here, and I show again, I can point you to where I make these. I created these, so I like my symbol this way with the circle against the wall. So let's get that in here. Now what I'm noticing is I'm seeing the actual extrusion box behind here. So let's go and see what's going on with the view settings of this power plan. This was created originally from the out-of-the-box Revit electrical template. Okay, so this whole power plan is set up as fine, and we don't want that. We want it set up as coarse. So that's something that I had missed apparently back when I created this template. So I'll have to take a note of that and fix that in my template. So there we go. Now we don't see the extrusion box behind the symbol. I only want to see a symbol. Another thing that happens with elevators is the cab itself needs a circuit for the cab lighting that they hook up. So let's get another connection here. Now this is not a motor, it's just an equipment connection. So what I have over here, another custom content, is this thing called ER equipment connection. So drag that in. I use this like a palette, and see it's similar, but it's a different symbol. So this is for the cab power. I'll put that in. And this time, I'm going to go ahead and duplicate this one instead of renaming it. So I'm going to duplicate this and just call it cab power. Now I'm not labeling ER1 or ER2 because I'm not so worried that they're going to be the same cab power. Both will have the same kind of connection. And I can put two of these in, just has the same type. So load classification equipment, and it is going to be a single phase 120 volt connection. So this is right. I don't know the exact load, so I'll leave it bumped up around 1500 VA, which is a very conservative number for that. And this is already set up to be on the equipment schedule. I don't want it there, so I'll erase that. Its description by default was heat, and we're just going to call it elevator cab power. A lot of these are just notes for us, for our team. If you have other electrical people working in this, it's very handy to leave some documentation. And we will just call it cab power. I don't really have a special marker for that. And we'll leave it fused. And then let's also tag this thing with a leader. And we'll call this cab power. And it kind of fits in our symbol. Now we want to do the same thing to the other elevator. So what you can do instead of dragging them over is you can just right click and say create similar. And there we go. And come over here and pan over and put this guy right here. Now this guy we want to create our own. So we will go up here to elevator 1, edit the type. Let us duplicate this. And it tries to change the name for us and it failed. Elevator 2. We're going to say it's the same load. Its description is elevator. And its type mark is going to be LEV-2. So we're good there. And let's tag it. Elevator 2. We also need the rest of this, so let's just create similar for the receptacle. Save it when it wants me to. A good practice to get into. And then we'll put this guy in here. Again, you'll want to consult your shop drawings when you get those. But a lot of times we find ourselves actually putting placeholders in, taking our best shot until we really know what's going on later. In fact, many times I get asked to size the main service for a building before I've even designed it. That's a whole nother issue. So this guy, cab power, we're okay leaving it as cab power. And we'll get this drawn over here. Now, if you don't like where the arrow ends up, you can always click on here and say leader type attached end. You can unattach it, say free end. Apply it. And then I have free reign over where this arrow lands. And then the storage room, sometimes I'll put a receptacle in a storage room. It's a design decision. It's up to you. Sometimes we don't. So I'll leave it out this time. Also stairway. Sometimes we get a receptacle in a stairway for cleaning equipment. Another design issue. So you may want to talk to the architect or owner about that. But those are the main pieces of equipment for the elevator. However, we also need to remember that the elevator pit gets some power. So there's usually a receptacle in here for their maintenance, and they'll tell you where they want it. But let's put it over here on the side for now. And then also associated with an elevator, if you check your HVAC and plumbing plans, there may be a sump pump. Now, we'll be checking with the HVAC design and plumbing later. We're assuming right now that they're currently starting design just like we are, so we don't have their information yet to include. Eventually we will. And eventually we will actually link their model in here for some three-dimensional coordination as well. So let's get that receptacle in here just for maintenance receptacle. So we're good on the power side. We're not going to put any convenience receptacles in the parking space itself. However, depending on where you are, you may have jurisdictional requirements to get electrical vehicle charging put into multifamily. Around here, up in the Northwest, they're requiring at least we have capacity for 40% of the parking spaces shall be, again, have the capacity for at least a 32 amp charger, so 40 amp breaker minimum at 208 single phase. So we've had to include those in our projects lately. So we're going to go ahead and put some charging in. And it looks like we have, we can count these up. Looks like we have about 20 spaces in here. So 40% of that is 8 spaces. And we want to make sure we get a handicapped in there. I always want to make sure we have a handicapped area that has a charger. So 1, 2, 3, 4, 5, 6. And then that handicap can have one. And then we'll say this last space can have one. So what I'm going to do for now is, again, we'll say that we've talked with the architect, we've talked to the owner or the powers that be and decided where they want these charging points. And whether they're hooked up now or later, we'll deal with that later. But for now, what I'm going to do is bring in my EV charge station, my dual circuit bollard. Again, I have a video that covers how to create this custom content. I'll link it in the description below. Let's bring that in, and it looks like a ChargePoint brand of charger. Now, in a garage, this would not typically be a bollard. It may be a wall mount. But I'll use this symbol for now, and we can go back and get creative with a wall mount if we want. But for my purposes, this works. So I'll get this near the wall, like that. And something we can do right now is look at this in 3D. Let me show you what we can do. We can surround this and then go up and hit this little guy here under View, Selection Box. If you hit that, and it depends on how big your model is, it will create a 3D view with this section box, it's called. This blue box here, that's the model. There's a blue box right there, section box, that you can grab these little grips. You can barely see them, but you can grab these little grips and move it up and down. And now I'm in the floor above, so pull it down. But it gives you a little 3D view of your space. Again, we're not doing a lot of 3D work yet. Most of our work electrically is in 2 dimensions. But this will give you an idea, and this shows my little EV dual charger right there. So it's a pedestal mount, and that's fine for now. We'll get that adjusted later. But for now, I just want to at least get this thing in and get it circuited. So here's our elevator shaft, and look how detailed they've gotten with even the elevator lights and the buttons. They've really gone to town on this one. We have the rails, we have so it's a hydraulic shaft. You can even see some of the lights in here that we'll be catching later. Those are in the architectural model. But that's a little 3D view. It's kind of fun to see what we're working on. And then I want to go back to my parking level power. This will serve 2. I need to copy this over and put another one here for those 2. We can get that a little more centered. And then let's say we'll do these other 2. And then we need 1 for this handicap. Again, I only have duals in here right now. So we'll use that. And we can just connect one side of it for now. And then I'll put another one way over here. All right. And then we can go into these, and these are all the same type. We don't need them individual. They don't have individual names. But what we can do is get a type mark in here so that when we tag it, we can put something like EVCHG for EV charging point. And as you know, the charger is actually in the car. This is just where you connect power to work the charger. So it's a charge point. And then we can tag these. I like to tag things so we know what these little things are. Now, if we want to call these some of these future, we can create a separate type and just put future EV charge. Well, let's say we're going to get these guys all EV'd up right out of the gate. 1, 2, 3, 4, 5, 6, 7, 8. All right. So looks like we have our power needs for this parking level set up. And until we get some HVAC loads or plumbing loads, we may have some sump pumps, or we may have some exhaust fans in here, things like that. We don't have all that yet. But let's go ahead and get this stuff connected. So what we're going to do is start a distribution system. I kind of like to start off by creating a one-line or single-line diagram of my building. Well, I haven't gotten that far in this project yet, so I'm just going to start now at the bottom and work my way up and just put in some panel boards. If you have the luxury of doing it that way, it's kind of nice because then you don't have to do square foot calculations and load calcs and try to guess all these distribution boards up front. So we're going to say that we have time to do that, and we're just going to size this as we go. So what I have over here is some of my custom content, but what I'm going to do is get rid of all of these out-of-the-box pieces. Now notice that the out-of-the-box panel boards are separated. They have a number of families. They got 208 main circuit breaker, 208 main circuit breaker surface, a 208 main lug only, 208 main lug only surface, and you have all these different families. What I did is I went through and I just created a surface panel board, you can have any voltage, and a recessed panel board, you can have any voltage. I did the same thing for my switchboard, and I've not made videos on consolidating those yet, but I will make videos that will show you how I consolidated all these different panel board families into simple families that are adjustable. So let's go into Insert, Load Family. Down here I have let's go down to my panel board. I have a recessed and a surface. They are different 3D geometry. And then I have an ER switchboard. So bring those all in. And they're up converting from 2022. So there, let's get rid of all these out of the box. I use their transformer for pad mount if I need it, which I probably won't. And I also use my own dry type transformer, but I'm not going to have any in this project. We're a 208 project. So it should be good to go. For distribution wise, we're going to have a main coming in, but we're also going to have a house distribution board that's on its own meter. Because this building has tenant spaces, like for retail, as well as residential units that will be all separately utility metered, we are going to have some meter banks, and we're going to be feeding a house distribution panel. So I'm going to put in a house distribution panel to run these elevators. So let's go ahead and just bring one of these panel boards in here. I'm going to use a surface panel board. You can see I already have the two voltages set up because those are tight parameters. Let's bring in the 208 and let's just put our house panel. We're going to have our main panel and meters over here. So I'm going to put a house panel over on this side for now. This is my custom panel. It has clearances in front of it and it has a door. So I'm going to call this guy. Let's first of all, what size are we going to make it? And you can see I don't have different types of sizes because the amperage of this is not a type parameter. It is an instance parameter. This instance of this panel board is going to be, let's say it's a 400 amp, and we can change it later. Now, I'm not going to have a main circuit breaker in here. Sometimes just for that reason, I'll put this down to 1. So then when I'm looking in here, I realize I don't really have a main circuit breaker. I can't put 0. And then I need to give this a name, and this is going to be called the house distribution panel. Let's call it HDP. Okay. And then we will tag this, and I don't want a leader. So there's our HDP. And then we want to connect the elevators. Now, it depends on the jurisdiction you're in, again, as to whether you need an elevator or elevators on emergency. You need a generator. You need 2 different utility connections for backup. So in this building, we're just going to say that this building does not require an emergency system, and we can put one in later for an example if we want. For now, we're just going to connect them all to the utility power HDB. So let's go through and get these connected. Now, this is a distribution panel, but we can also use it to connect other house loads like the receptacles. If we need to break it out into a separate, smaller panel, we can. But for now, we'll connect it all. So let's start with here with our elevator number 1 way over here. So you click on it, and then we have the power button. So you hit the power button, and then it asks for which panel do you want to connect it to. Now I can just drop down and find my panel, or I can say select panel, and then go physically find it and click on it. And if it's on the same floor and it's easy to get to, this is an easy way to do it. So now I've connected to HDP. It assigns the circuit in the order that we've chosen, and we've already set that up in our template to be 1357. We're going to go down the left side of the panel board and then down the right side of the panel board. And that's all in my video about setting up your template. So the rating on this, right now, we're going to say it's a 100 amp trip, and that can be changed later. Now the load name, it brings in the load classification by default, but this is the name that's going to show up in the panel schedule directory that'll say, what does that breaker serve? So I like to be a little more descriptive. So I would do something like elevator 1 so that the end user knows what that breaker does. It's a 3-pole breaker, and we can say apply. We're still in the circuit. Now what we can do is we can add a home run arrow. Even though my 1-line diagram will actually size this feeder, I'm not going to size it on this plan here. So it shows this as an underground conduit, as you can see up here. In a previous video, I show how you can create dashed underground conduits. I'm going to leave it as an underground conduit right now because we most likely will run this under the slab. But I'm going to move it a little bit so it's not in the wall. And I can even move my little circle. And then I can give it a home run tag, no leader. And I have this set up with a custom tag for panel, dash, and then my circuits. And some people use a slash, and there's all different kinds of ways to do that. You can customize it however you like. And I have a video that shows you how to do that, which I'll put in the description below. And then I also want my cab power to go to that panel, so I can do the same thing. Power. It's only going to list panels that are available at the voltage that this is, which is 120 or 208. And I only have one panel right now anyway. So HDP, it assigned it the next breaker in order. We already used 135, now we're in 7. This guy, not just equipment, we're going to call it elevator 1 cab power, something descriptive. 20 amp breaker is good. So we apply that, and the wire type is underground again. And let's arc that. And I'm going to put that arc up here and get that dot right there. Get the tag on this home run. And then let's do the receptacle. Power it up, same idea. And we're going to call this receptacle elevator 1, or maybe machine room. Machine room PO2. And it's 20 amp, which is good. We're in commercial here. So arc it. That looks good. And tag the home run. As simple as that, those 3 things are circuited. Let's go look at the panel schedule so we can follow along. We need to create a panel schedule. Now what you can do is just click on this panel, and up above it'll say create a panel schedule. The other thing you can do is go up to Analyze and go to Panel Schedules, and it'll give you a drop down of the ones you haven't made yet, and you can say OK. And it creates a panel schedule, and that will end up over here in your project browser under Panel Schedules right there. And it names it the same we named it, and here we go. And we have this set up to show multi-pole breakers. It takes the dividing lines out of it, makes it one big cell, which is what I like. And it has the names that we typed in. You can see circuit description was that load name. We have things set up properly so that it divides up the loads amongst all the phases properly. Shows our mains rating. Now we're going to need to change this schedule so that we don't have a main circuit breaker. But then down here we have all of our load classifications nicely sorted. So we know the different kinds of loads and their demand factors. In this case, we're all at 100% so far. And then if we move this over a little bit, we can see the full panel. And it's a wide one. You can use the control key and scroll to shrink or enlarge the panel, just the view of it. So pump it up one more. And down here we can see here's our total connected amps and estimated demand. Since everything's 100%, it's all the same right now. But that's where we are. So now we can continue circuiting. Save it, of course. I realize we also did not get this elevator connected here. This guy and the machine room and the hoist, the elevator folks want those on separate circuits. So we're going to get this also powered up as we did before. Receptacle, elevator 1, hoist. And we can get tag on this home run as well. So we're heating up our circuits. Now we can do the exact same thing over here. I'll do that really quickly. And there we go. Simple as that. Now I'd like to get these chargers connected, and I often will put a separate panel board for the chargers. It leaves a panel board available for future chargers as they want. We can upsize it, and I just like to keep those on their own separate charger. You can also meter those separately if you like. Now, a lot of energy codes in different states have metering requirements. sub-metering requirements by the landlord, by the owner, to meter HVAC separately from receptacles, separately from lights. So if you have that situation, you'll want to break up some of these loads as well. And that's very much a local jurisdiction thing. And it's energy code. But for this one, we're just for convenience, we're going to put these on their own panel. So we are just going to create similar from this guy, create similar, and we'll put it right here. We'll call this one panel name. Let's call it EV for electrical vehicle power. And the mains, we'll have to see what we come up with for the size. For now, we're going to go 225. And also, this is where you put the maximum number of breakers. And if we need an 84 circuit, or if we only need 30 circuit, we do it here, and the panel schedule will follow suit. So let's get a tag on him, EV, and then let's get our EV chargers connected. Now, what we didn't do is, when we created these, we didn't go in and set them up. Let's see what we have. Yeah, so we're going to go ahead and set these up. We have two connections. Load 1, pole 1, voltage 1, load 1, and then classification 2, 2, 2, 2. So we have two different connections in here. So these are load classification. We have an EV charger load classification. We're going to go 2 pole, and we're going to go 208. These are just level 2 charge points. And the load on these, we're going to do the 32 amp ones. So it's 32 times 360, the magic number for 208 again. 2, voltage 208. And the load, and I just realized I'm wrong. It's not 208 3-phase, we're 208 single phase. So the magic number is just 208 volts times amps. So that helps a lot. 32 times 208. There we go. Close to a 7 kVA charger. Okay. And that changes all of them because they are all the same type. But now we can circuit these one at a time. Power. And we're going to do connector 1 first. Again, I show in a video how to create this dual circuit charger. And let's call it charge point. And radius is going to be 40. I've seen a lot of these level 2s even up at 100 amp connections. So that's good for like an 80 amp draw. And let's arc that. We've got one there, and we can give that. Now, look what happened here. I didn't pay attention, and it automatically assigned it to the last panel we used. I don't want it on HDP. I want it on EV. So what I can do is click on this and go up to electrical circuits and change it that way. Or I can hover over it, hit tab a couple times until you see those blue dashed lines and click it. Now I've selected this circuit and I can change it from here. So now what I can do is simply go to panel and drop down to EV. And look at that. It automatically put it onto EV13. So it's very convenient for changing circuits. So now we have another point. And as you can see, when I click on it, I still have the power button. Well, it's going to automatically to the power connector 2. So do that. I'm going to EV this time. I'm paying attention. And we're going to call this EV charging charge point. And we have a drop down now. And then we can apply that. And then let's circuit that. And we'll get that down here. And let's put the tag on that. So that assigned it to EV5 and 7. Now these wires are going to be larger than a number 12 because we have a 40 amp breaker. So we can put wire size on here, or we can deal with it somewhere else. Some people put that on their panel schedule. So we'll come back and button all that up. We'll also check for voltage drop, things like that later. But for now, I'm just going to let this stand the way it is. And then here, we just want to power these up again. Connector 1, EV, change this, and we have a drop down now, so it's easy to put charge point and then arc it. And we're getting to easy mode now. And there we go. You can see how fast circuiting can be in Revit once things are all set up. And that's the key. It has to be set up. These guys, and I'll just quickly go through the rest of these. Now this one we decided to just do a single circuit, and we can come back and change the symbol and all that later if we want. Sometimes at schematic design, level design development, I take a few shortcuts because I know it's going to change anyway. This whole parking lot could change configuration before we're done. And then we have the one more single circuit here. Connector 1, EV good, charge point good, and get a little bit of a curve to that one. And there, and let's go ahead and make a panel schedule for EV this way. Create panel schedule and use, let me see if I can choose template. Now I don't have yet in this template my main lug only branch panel, so we'll have to create that. Again, I'm still working on my template. If you watch my template video, you'll see there's a lot to it, and you can just keep adding on as you go. So here we go. We're down at 148 amps with those 8. So, you know, we've got another 80 amps available, and we may want to bump this up to a 400 amp panel before we're done, but for now this works. And another thing I'd like to do, I want to get a receptacle in this utility room, and I can just create similar, get a receptacle in here, and get this powered up to, now I'm not going to worry about underground for this guy. And we can change the wire type to just THWN. Nowhere will you ever see what wire type this is. If it says XHHW or THWN, the insulation type doesn't really matter in here. It's just wire. And it's going to call it receptacle, electrical room, 20 amp, good, arc it, and get a tag on it. And you can see it's a solid wire. Solid wiring. It'll just be run surface in here. So I'm going to declare that parking level power for now is complete. So the next video I suggest you watch is here on the screen now, and it's about how I created these motor circuit symbols. So take a watch. Until next time.